Good morning, everyone. My name is Katarzyna Gromek, and I am an independent researcher working in the United States of America. First, I would like to thank you, the organizers, for inviting me to the 13th edition of Experimental Archaeology Conference and allowing me to present the results of my experimental work. The title of my talk today is Stypsis, Wine and Resin, Technology of Scented Oil Production from Bronze Age Aegean and Beyond. I will start with a brief introduction to the technology of scented oil production in the Bronze Age Aegean. Then I will present my experimental work, discuss what worked and what failed. We will look at the estimates of scented oil yields and at changes observed in oil exposed to stypsis and further processing. First, let's have a look at the processes used for making fragrant oils in the Middle and Late Bronze Age in the Aegean. With no extant descriptions of the stypsis and following processes from the Middle and Late Bronze Age Aegean, the closest work we can consult is the treatise on odors from 4th century BC, written by Theophrastus of Rhesus. Theophrastus described the nature of the stypsis process as making the oils more suited to take in the final odors. He compared this process to pretreatment of wool for dyeing. Usually, the less powerful spices with high astringent properties, like nutgrass or sweet flag rhizomes, were used for the thickening process, which was enhanced with gentle heating. The astringent substances were collectively described as stima. After initial processing and separation of oil from the stima matter, the aromatics with stronger scent, called hedesmata, were added to the oil, with the last ingredient added making the most impact to the final olfactory profile. Theophrastus recommended avoiding direct contact with flames to prevent the smell of burning to permeate the final product. Lacking extant texts with recipes from this region, we can consider the results of organic residue analysis of samples excavated from the Aegean region instead. One of the earliest analyzed samples comes from Zokomino, a copper smelting site on the northeast coast of Crete, dated to 2200 to 2000 BC, the Middle Minoan. Analysis of a sherd from a wide and shallow jar, called by authors of the paper a bucket jar, with the volume around 927 milliliters, revealed that it contained a resinated wine mixed with aromatic or medicinal ingredients. It was protected from air by a layer of plant oil, most likely olive oil, to prevent its oxidation to vinegar. Next, we have an amphora from coastal site of perfume workshop in Mochlos, East Crete, dated to around 1500 BC. Analysis revealed that the amphora contained olive oil, coriander, camphor from a highly camphorous plant like Artemisia species or other Mediterranean herb, sweet gum resin, rock rose resin, and blossoms of linden tree. Then we have the linear B script tablets from the palatial site of Pelos Mycenaean culture, dated to the late Bronze Age. Those were mostly records prepared by scribes associated with the palace workshops and storehouses within the palace. These records were taken within the last few months before the destruction of the palace in the springtime. Since those are inventory and distribution records, we only learn about the ingredients used in fragrant oil processing. This includes large amount of coriander seeds, which were absent in the classical antiquity texts related to fragrance making, nutgrass rhizomes, wine, honey. And we have a peek into types of oils supplied to the palace, like rose-scented and sage-scented ones. The last sample comes from a stirrup jar from the Toloti Plakalona site in eastern Crete, dated to late Minoan period, around 1175 BC. The results of chemical analysis are like the sample from Mochlos, with one ingredient missing, the linden blossoms. The absence of these blossoms could reflect the climate change which occurred at the end of the Late Bronze Age. Now I will present my attempt at reconstruction of selected fragrant oils. We will start with the Chrysokamino medicinal oil. The process starts with grinding coriander seeds and macerating them in olive oil mixed with dry red wine of Aglanico type. This wine was supplemented with Aleppo pine resin. The heating system used in this and all the following experiments, consisting of cast iron stand and a single tea light, does not allow the temperature inside the pot to raise above 60 degrees Celsius. After processing with heat for around 24 hours, the stima mater is removed by filtering the oil and wine solution through a linen cloth. I estimate that half of the initial amount of wine evaporated during the heating process. In the second step, the ground aromatics of the hedesmata, in this case the rue, oregano, licorice roots and rosemary leaves, are added one by one and allowed to infuse the oil for several days. At this step, the heating is applied every second day for 6 hours. The last ingredient to be added is wild rue or esphant, and this ingredient brings out the bitterness to the final olfactory profile. Looking back at the original description in the paper, this is the Stypsis process caught in action. My experiment with wine supplemented with 6% Aleppo pine resin and without sulfite preservatives revealed that such wine is extremely stable and do not oxidize to vinegar at least for 5 years. Additionally, the shallow white pottery container was better suited for heating than storage. Next, we have the Machlos linden blossom oil. Here, the presence of coriander in extant sample suggests it can play a role of astringent. This time, for the Stypsis process, I used white wine of Malvasia type, supplemented with terebinth resin from Pistacia terebinthus, and proceeded to gently heat the oil and wine and coriander mixture. After removing the stima aromatics, I added the hedesmata ingredients one by one, starting with labdanum resin, wormwood, sweet gum resin, which is also called storax. After heat processing, the olfactory profile was intoxicating, thanks to the labdanum and wormwood volatile ingredients. Then the linden tree flowering tops were added as the last ingredient and allowed to steep in cold oil. I repeated this process 3 times to achieve good odor saturation. After removal of the linden blossoms, the oil still contained wine and plant waxes. This is the lower layer at the bottom of the flask. I let the 2 phases to separate before transferring the upper oil phase to a new container for storage. Any leftover water can create conditions favorable for spoilage. The pillow sage scented oil was prepared in comparable manner. I started by macerating the ground coriander seeds and nutgrass rhizomes in the mixture of olive oil and water. Quick temperature check confirmed that the liquid inside the pot did not overheat. After heat processing, I separated the liquid phases by squeezing plant matter in linen cloth. The final yields of oil depend on efficiency of removal of the plant matter. To process larger volumes, this step of squeezing oil in cloth would have been performed by a team of 2 people. Using a large bundle with attached sticks at both ends would allow to apply more force and recover more oil. Since this is a single aromatic scented oil, the next step consisted of adding roughly crushed sage herb and heating the mixture for around 24 hours. Most of the leftover water and wine evaporated during this step. Next, I added powdered henna leaves, which were pre-soaked in wine to release the dye. Initially, the final product seemed to be colored, but after decanting and second filtering, the color returned to the greenish one, coming from the herbs. The last oil I will present here is the raw scented one from Pylos. Again, I started with adding stima aromatics, the nutgrass rhizomes and coriander seeds, and then I followed with gentle heat processing. The hedesmata aromatic in this case are the fragrant rose petals. They were first processed by cutting off the white at the base of each petal. Then I smeared honey on my hands and proceeded to crush petals a bit in preparation for the cold steeping process. I repeated the cold steeping process 7 times, like in the description of preparing rhodinone oil, described by Dioscorides in 1st century AD. I stained the oil orange-red with alkanet, and then decanted it to separate the water phase from oil. Not everything worked as expected. I was unable to color the oil with henna, known in the linear B script tablets as ertis. I prepared henna as paste in wine, knowing that the pH values for all used wines are within acidic range. Unfortunately, after the removal of the henna matter, the oil still preserved its greenish tint. It is impossible to measure the pH of the oil itself with the equipment available to me. Here we have examples of how the color changed from the raw untreated oil to final product. The greenish color of sage-scented oil comes from the herb. I also pretreated henna paste with vinegar, though it did not resolve the issue. Now we will look at the yields of fragrant oils. I have compiled here the initial volumes of raw oil and weight of stima aromatics and the final yields of scented oils. The process of making fragrant oil is not very efficient. My best yield reached around 57%, while the lowest was barely 26%. Since my experimental work stretched over 5 years, the amount of stima ingredients were adjusted as I based them on the results of previous experiments. I started with low ratio of stima ingredients to oil, in the range of 2.5 to 2.9. As I observed changes happening in maturing oils, I have started to increase the weight of stima ingredients used to pretreat the oil. My latest oils were made with ratio of 1.67, which means I used 1 gram of aromatic to treat 1.67 gram of oil. This is more in line with recipes preserved from 1st century AD. While coriander seeds do not appear in extant oil recipes, analysis of excavated samples clearly indicates that coriander seeds were used in oil preparation. When we consider the potential role of coriander, we should look at the use of sweet flag and nutgrass rhizomes. Comparing coriander seeds to green cardamom is like comparing apples to oranges. Essential oil content in dry coriander seeds is similar to amount present in sweet flag and nutgrass rhizomes. It is on average below 1.2%. Essential oil in dry cardamom seed is within 4 to 8.7%. The tannin content is similar across all these plants, being around 2.5 mg per gram of dry weight. Tannins are in part responsible for the astringent properties of oil, while essential oils are adding the new odors. If we reconsider the amount of coriander seeds needed for pretreatment of raw oil, the recorded volumes of oil and raw ingredients in the Pillows Linear B script tablet make more sense. If 1 gram of coriander seeds is needed to treat 1.8 gram of oil, then the maximum amount of processed oil decreases to 2,083 liters. The calculations for total oil production published so far do not consider any losses during standard oil processing. If we adjust the volumes for the lowest loss observed in my experiments, 43%, we can further decrease the total oil amount to 1,187 liters. This amount agrees with the total oil volume recorded in the tablets. We must remember that the records were fragmentary and only represented a few months of the past activities. To sum up the major points, most benefits of the Stypsis process apply to the stability shelf life as well as quality of final product. The resin present in wine acts as fixative and gives a depth to the final odor. Both wine and resinated wine extended shelf life to at least 3 to 4 years and allow the oil to mature well. Pretreatment only with water gave an oil with flat medicinal scent which did not mature well. Regardless of ingredients used for Stypsis, the oil became visibly thicker, which can be explained by removal of water content through evaporation. Both wine and resinated wine made the oil astringent, which can be felt as excessive drying and tightening when the oil is applied to skin. The red wine has high tannin content, which explains its role in making the oil astringent. Considering all the changes observed in the final product, I can confirm benefits of pretreatment of oil with Stypsis. Thank you for your attention, and I hope I was able to convince you that Stypsis is an important part of technology of fragrant oil preparation.